2019, 21st of January. The following ARMA 11 model has been fitted to the time series X. You have the output of the estimation process produced by R, and in figure 1 you have the estimated autocorrelation and partial autocorrelation functions. In figures 2 and 3 you have some model diagnostics. And the questions are: is the model fitting satisfactory? Explain. Which steps would you follow in order to fit an ARMA gauge model? Okay, this is the time series. Let us reduce the size of the image. Okay. This is the raw time series, and the estimated autocorrelation and partial autocorrelation functions are shown below. Well, one thing you can notice is some changes of variability in the first part, in the second part with respect to the first part. So you might have some kind of volatility clustering in this time series, but notice that the role played by autocorrelation might raise this behavior even when the variance is constant over time, as we haven't seen during the lectures. So let us check for the model fitting before hypothesizing any kind of heteroscedasticity or conditional heteroscedasticity. This is the plot of the standardized residuals. You can notice that still in these residuals you have some changes in volatility here and here. And so you might suspect that something should be done in order to cope with this behavior. The estimated autocorrelation function is quite satisfactory, actually, as can be noticed by the correlogram in the second plot or by the p-values of the Ljung-Box statistic. So this model fitting is not completely bad. You might expect that an ARMA plus gauge model might work better. And so you might think about fitting an ARMA 11 with gauge disturbances. So an ARMA 11 plus a gauge PQ model. The second question concerns the strategy you would follow in order to fit such a model. Well, you should explain how the model fitting for how you might identify a model for a gauge process. So you remember, you should, well, I neglected the third plot, the plot of squared residuals. Here you can notice it is more apparent that you have some traits of volatility clustering. You can notice that in some periods the squared residuals are much higher than in other periods. It is quite apparent in the first part of the plot. So, how could you fit a gauge model, an ARMA plus gauge model? You should check for the squared residuals. You should try and fit an ARMA model to the squared residuals in order to try and capture the order of the gauge PQ. After doing that, remember that in that case the autoregressive order couldn't be less than the moving average order because of the links that there are between the gauge model and the ARMA for the square of the process. After doing that, you should estimate jointly the ARMA plus Garch model. You should not fit a Garch model on the residuals. You should fit an ARMA plus Garch model to the observed time series. And then you should check for the uncorrelation of the standardized residuals of the new model you fitted, and check also whether the assumed probability distribution from the innovations in the Garch process is correct, or whether it should be changed. We have seen that we could look at that through the QQ plot or the quantile plot. But actually, you cannot say much more than this. And actually, I said quite a lot. When you answer these kind of questions, you can only base your statements on the data provided by the exercise, and do not adventure in imagining what might happen if or if not, or if what you assume might be violated, and so on. I do not require very long answers, so just explain how you would fit an ARMA plus Garch model, and that's more than enough.